Assalamu alaikum, dear students. As most of you know, we have finished our electricity portion in our crash course class. So, in today's lecture, I'll be solving MCQ questions of the same topic, which was electricity. And I'll be solving firstly its Majun variants questions of the Pakistani variant in easy wording. And right after it, I'll be solving its theory questions or structured questions in simple words. Firstly we will be solving P2 questions, and secondly we will be solving P4 question. Right here you can see it's your paper extended IGCSE with course code 062522 May June 2025. And as far as our topic is concerned, our portion is concerned, our topic was electricity, right? And the electricity question is basically it you're gonna find electricity question around after right 24th 25th question, right here exactly. So from 26th question there will be few questions which belongs to your electricity portion, and right after it will be magnetism and so on so on so on. So right here, let's start. Bismillahirrahmanirrahim. Question number 26. Positively charged, let's read it together. A positively charged balloon placed against a wall. The charge makes the balloon to stick with the wall. First of all, keep one thing clear in your mind. How charges will be sticked with respect to each other are, there was a phenomena which I have taught you earlier, or which you have studied earlier as well, like charges repel and opposite charges attracts. Yeah, attract. Okay, so this phenomena or formula or scenario will be applicable right here. So let's continue the reading of the statement. Which statement explains this scenario or situation? Positive charges on the balloon, as examiner has mentioned one thing, that your balloon was a positively charged balloon and it will be stick with the wall. So positively charged balloon will attract the negative charges of the wall. Okay, if it's positively charged balloon, then positively charged balloon will attract the negative charges from the electron to, you can say, neutralize it or something like that. A positively, first option, positive charges on a balloon attracts the electron in the wall. Yes, exactly, first one is the correct one. And let's check that why other options are not correct. Positive charges on the balloon attracts proton in the wall. The bit same charges will not attract each other, it will repel each other. Okay, the second one, positive charge, third one, sorry. The positive charges on a balloon repel electrons. No, bete. Opposite charges will attract each other. It will be attracting. Okay, it's also not correct. Positive charges on a balloon repel the proton on the wall. So it will also not gonna be corrected. Actually, the next one option. Sorry, the next one question. The question number 27 is telling you that our student is trying to determine the resistance of a lamp. Okay, the setup is, following setup is incorrect. Okay, as whenever I have taught you, whenever you will be studying the construction of a circuit, then you must take care of these two things. Lamp, it will be connected in series, it's all right. Parallel maybe ho sakta hai, it can be placed in the series as well, but the thing is there are two meters right here. First one is ammeter. Ammeter is basically current measuring instrument. It will it will be telling you the exactly reading of the um, current right here. And second one is voltmeter. Voltmeter will be telling you voltage or potential difference. Okay, so there is you can say a rule for the following instruments to be placed in a circuit. Ammeter must be placed in series. Ammeter must be placed in series. That's it, that's all, already in series, so it's also applicable, it's all right. Ammeter's placement is the correct placement in a circuit. Voltmeter must be placed parallel to the component, parallel to the component. So voltmeter placement is not correct right here. So mera beta, I'll just correct it firstly. So disconnect the ammeter and move it to the left of the lamp. No, Sir has told us कि ammeter should be connected in series, that's in correct orientation, but voltmeter should be in the parallel placement, which is not which is not present right here, which is not a correct situation of the question right here. Swap the position of the ammeter and the voltmeter. No, it's not the matter of swapping. It's the matter of rearranging. We have to rearrange. Disconnect the ammeter and connect parallel to. No, beta. Disconnect the voltmeter. It should be your voltmeter. Voltmeter placement should be different right here. Disconnect the voltmeter and connect it with parallel with a lamp or something. So that's a correct option right here. Okay, D is the correct option. Hopefully you guys have understood. So voltmeter and ammeter, and let me write that thing as well. Voltmeter tell you, your voltmeter can help you to measure potential difference, voltage, or value of EMF. These three values will be found by using your voltmeter and ammeter. Ammeter is basically the modified form of galvanometer, which will be helping you to calculate current in a circuit. All right, the next one. Metallic wire X has a resistance. Which difference in a resistance of the wire of the same material as X? Okay, there are two situations right here. Shorter than X and the same diameter, same length as X but the smaller diameter. First of all, let me tell you a clear situation that resistance of a metallic wires or metal will be depending on few factors. What is the main original relation for the resistance equals to rho L divided by A, rho L over A, normally rho L over A. Acha ji. So what is the situation right here? Resistance is directly proportional to length and resistance is inversely proportional to area. But यहाँ पे right here at a moment there is no reference of the area mentioned right here. So what will be my situation? So how I'll be just taking care of the following situation. As far as your area is concerned, area will be equals to area of the wire or metallic wire, or it will be equals to pi r square, and radius will be half of the diameter, so we are already familiar with it. Radius will be equals to half of the diameter square by 2. So right after taking this reading, we'll be just able to find it out, like by using this relation right here. We will be having a clear cut relation of radius is inversely proportional to square of diameter. Radius is sorry resistance is resistance is inversely proportional to square of the diameter. All right, and let me rewrite these things for to avoid the confusion. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of a conductor of the conductor. Sorry, resistance is directly proportional to temperature, and resistance is inversely proportional to square of the diameter. It has not been taught. Uh, Most of the time it's a minor point, so we used to skip it, but it's a very important point, and related to diameter there were multiple questions in your previous papers as well. So resistance of shorter wire, तो मेरा बेटा, if he is asking that, if examiner is mentioning that smaller the resistance is, sorry, smaller the length is, if your value of length is smaller, then resistance will also be smaller. Is that so? Shorter wire, smaller the resistance. Is that okay? So it's a direct relation. No? Basically, it's a direct relation. So I'll be choosing it I smaller, either C or D. Now, resistance of the wire with the smaller diameter as well. Mera beta, if we have studied right here a relation, resistance is inversely proportional to diameter ka square of the diameter. So if the value of diameter is smaller, then resistance will be larger. Okay, so in short, if you'll be making your exam notes, so then I'll be just guiding you a straightforward relation for length. Resistance is directly proportional to length, and second one is resistance is inversely proportional to square of the diameter. Larger the length is, larger the diameter. Smaller the length is, smaller the diameter. Smaller the diameter, greater the resistance is, larger the diameter, smaller the resistance will be. It's an inverse relation right here actually. Okay, so right here in our case, our diameter is smaller right here. Smaller the sir has told us, smaller the diameter, larger the resistance will be. So it will be the greater resistance right here. So C is the correct option right here. Okay, bacho. Right here, question number 29. Beta, before teaching you question number, before discussing question number 29, I'll be just discussing a situation of series and parallel combination with you guys. So right here, your circuit is basically a series sort of circuit. Okay, let me draw it in a series sequence, or if you want to just check it, then you can go for the following situation. This thing right here, you can check that it's a series combination of the circuit. Okay, there are two resistors right here, R1 and R2, which are connected in series right here. Okay, hopefully you guys have enough idea right now. So let's get back to the main situation. Let me solve it directly. Acha ji. So there are two combinations generally, combinations of the circuits. First one is series circuit. So beta, in series circuit, just keep one thing in your mind. Your current in a circuit, in the circuit, in series circuit will stay same. Current stays same. Voltage will be divided. Voltage divides. Okay, voltage, whatever the potential difference right here is, voltage right here is, EMF right here is, sorry, potential, not potential difference, EMF or voltage right here is, will be divided into R1 and R2. Okay, if these are identical resistors, R1 and R2 are identical resistors, then this potential, this energy, this voltage, this EMF will be divided into these R1s and R2s equally. Okay, if not, then it will be the ratio proportion 1:2, 2:3, or something like that. So that's another situation, or another discussion which we will be having some another time, or sometime else, inshallah. So resistance of your series circuit, total resistance will be equals to sum of all the resistances, R1 plus R2. Okay मेरा बेटा. Now second combination is beta parallel combination. Okay, in parallel combination, current will be, current divides, second one is voltage stays same, and the third perspective was your total resistance or equivalent resistance will be equals to 1 over R1 plus 1 over R2. And sometime directly we'll be using a relation for it, is product over sum. The scenario or situation which I have written for this formula which I have written for the following situation is, our scenario is, it belongs to only two resistors. Whenever you will have two resistors, then you can use this relation, R1 multiplied by R2, R1 plus R2. This one is your product over sum. This one is your what? Product over sum. So this one is series circuit. So mera beta, first of all, I'll just keep one phenomena in my mind, like sir has told us, current stays same, current stays same. So if current stays same, then for the for the first resistor, what will be the value of current right here? So according to Ohm's law, V equals to IR and I equals to V divided by R. So मेरा बेटा, for the first resistor V1 R1, and for second resistor I equals to V2 divided by R2. Okay, it will be what? V2 divided by R2. So sir has told us both the resistances, in both the resistances current will stay same. Then मेरा बेटा, you will equate them, same rule, left hand sides are, the equations are same, then right hand side will be equal. You can consider them equal. V1 over R1 equals to V2 over R2. So right here we are having a relation we are having an equation related to v1 only, so I'll make v1 as a subject right here. But firstly I'll check that along with the v1 what are the extra things. r1 is the extra term. I'll just move it towards the right side of the equation, so it will get you what, v1 equals to v2 multiplied by r1 divided by r2. Please check if there is a relation, if there is a equation or question, sorry, equation or formula of this derivation. You can find it easily right here in your answers, v2 r1 divided by r2. So right here it's your b option. B is the correct option right here. All right, the next part is a very simple question, bacho. So diode, electrical device which will be converting alternating current to the direct current. So I have just unconsciously asked, told you guys earlier, it's diode. So diode is basically a p-n junction, positive side and negative side, it's a p-n junction. So it will be forward and reverse bias, and you must have an idea about it earlier as well. So that device which will be converting AC into DC, that is your diode. Okay bacho, that is your what, diode. Now the next part of the question is, I thought, okay, I'll be making this video of 10 or 20 minutes max, but the first portion has just consumed 16 minutes or something. But inshallah I'll be just real quick in the next questions as well. Asha ji, question number 31st. A cell is connected to a parallel combinations of 2 ohm and 4 ohm. There are two resistors right here, R1 and R2, 2 ohm and 4 ohm, which are connected parallel with respect to each other. The current in R2, which means this one 4 resistor, is 1 ampere. Current is 1 ampere. So what is the current in a cell, in the cell, which means you need to, cell stands for what right here, in a complete circuit you need to find the current right here. Okay mera beta. Now then let's calculate it quickly. So let's calculate the potential first. Potential of your voltage of second resistor. So what was your ohm law? I have told you in the last question, v equals to IR, and v equals to what is I, 1 ampere. Current is 1 ampere right here, and R is what, 4. 1 multiplied by 4, so voltage is what, 4 ohm right here. Ohm is the, sorry, 4 volts right here. 4 volts right here. So what is the unit of volts? Voltage का unit क्या होगा? What will be the unit of voltage? It will be volts. Okay. Now Sir has told us, in a parallel combination of resistors, voltage stays same. Okay, that was the main reason, like I have discussed each and everything in the last portion. So right here voltage is, in this portion, voltage is 4 volt. Right here in this portion, what will be the voltage? Voltage will stay same. Challenge, let me rewrite it again. Voltage stays same in parallel combination of resistors. Parallel circuit या parallel combination, you can write anything whatever you want. All right, now if we are given with voltage of 4 volts right here, and resistor, this one resistor R1, R equals to 2 ohm, then let's find the current right here. Let's calculate the current at this portion. Okay, let's calculate the current right here. What is the value of current? I'm not familiar with it, so I'll apply Ohm law again. Ohm law will tell you what, bacho? Ohm's law, V equals to IR, and what do you need? I need current. I equals to V divided by R. So मेरा बेटा I equals to V divided by R. What is the V right here? V is, voltage is 4 volts, and resistance is 2 ohm. So what will you get right here? I equals to 4 divided by 2 will give you what? 2 ampere. Is this the final answer? Few students will be marking 2 ampere right here, but it's not a correct option. He has asked you what is the value in a cell. Cell will be considered as a complete circuit. So मेरा बेटा total current will be equals to current from your 2 ohm resistor plus current from your 4 ohm resistor. The 2 ohm current from your 2 ohm resistor is 2 ampere, plus current from your 4 ohm resistor was 1 ampere. So your total current is equals to I total equals to 3 ampere. So your correct option is right here, it's D is the correct option right here. So D is the correct option